Hi, let's learn about string concatenation. In this lesson, you're going to revisit the first objects that you learned to use, strings. As a reminder, a string is an object. There's a string class with its own attributes and methods. When you create a string variable, the variable stores the memory address of the string object. Additionally, the string class is part of the java.lang package. This means you don't need to worry about importing the string class like you have to do with the scanner class. Alright, now that we've done some review, let's learn about some important characteristics and abilities of strings. Strings can be concatenated or combined using the plus sign. In this example, there are two initial string variables, first name and last name. The third line is where the concatenation is, which you can identify by the plus sign. This line creates a new string variable and sets its value to first name plus last name. First name has the value of Carol, and last name has the value of the dog. So when these two strings are combined, full name is assigned the new string value of Carol the dog. When this is printed to the console, you get Carol the dog. You may be thinking, there should be a space between Carol and the. There isn't a space right now because there isn't a space in the first name string. When you concatenate strings, they combine as is. If you want a space to be included during concatenation, you have to include it as one of the strings. So, if you add a space as part of the concatenation, the space will be included when you add first name and last name together, resulting in Carol space the dog. As you begin combining and manipulating strings, it's important to know that a string object is immutable. This means once a string object is created, it cannot be changed. Let's walk through an example to better understand the concept of immutability. The first line of code creates the string variable name that references or points to the string object Carol. Then, the variable name is assigned a new value that concatenates the current value of name, Carol, with the string, the dog. This creates a new string object and updates the variable name's reference data to point to the new string object. There are two important things that happened here. First, the variable name is assigned a new string value, so when it is printed to the console, you get Carol the dog. And the second important note here is that the original string Carol remains unchanged because of string immutability. Even though name no longer points to it, it remains at memory location 0x005. Java actually has a special place of memory to store strings called a string pool. Java can use the string pool to optimize memory usage by reusing existing string objects. For example, let's say there is another line of code that creates a string variable named dog and assigns it the value of Carol. When Java creates a new string, it first checks a string pool to see if an identical string already exists. If the string already exists, like it does in this case, Java will point to the existing string in the pool instead of creating a new string. This is actually why you typically don't use the new keyword when creating a string. When you create a string without the new keyword, Java automatically handles the string with the string pool. For variable name 1, there are no strings in the string pool yet, so Java adds Carol to the string pool. For variable name 2, Java checks a string pool and finds the same string. Woohoo! Java can just reuse this string and have name 2 point to the same string object as name 1. For variable name 3, the new keyword forces Java to ignore the string pool and create a new string object outside the string pool, even though the string already exists. So while you can use the new keyword to create a string, it's more memory efficient to create strings without it. Now that you have a better understanding of how Java handles strings on the back end, let's go back to concatenation and see how you can concatenate strings with primitives and objects. You can also concatenate a primitive value with the string object. In this example, the integer value 10 is concatenated with the strings Carol and is. This results in the string Carol is 10. When a primitive value is concatenated with the string object, Java automatically converts the primitive value to a string in a process called implicit conversion. Implicit conversion can be tricky, as data types operate a little differently than you might initially expect. Take this program for instance. What do you expect the answer to be? Take a moment to pause the video and predict the output. Java works left to right, so it first evaluates the concatenation of the string literal with the int current age. This results in the string, in 10 years, 20. Since the 20 has already been concatenated and converted to a string, the second concatenation puts the 10 at the end instead of adding 10 and 20 together, as you might expect. To force Java to add first, you can add parentheses around the addition. With parentheses, the order of operations changes, and the two integers are added before they are concatenated with the string, resulting in the expected behavior. You can also concatenate an object with the string. This automatically calls the object's toString method. In this case, the rectangle class has a class-specific toString method, which overrides the object class toString method. This prints out the rectangle's width and height values. Now that you know the basics of using concatenation to combine strings, it's your turn to give it a try.